Hello everyone. Today we'll be solving the tree node SQL question. In this question, we will classify nodes in a tree structure into three categories: root, inner, and leaf, based on the information that we have in the tables. Before going further into it, let's do a recap of what a tree node classifies as. So each node in the tree can be of three types. First is a leaf node. If the node is a leaf node, it's self-explanatory. If the nodes are at the ending of a tree, they are called the leaf nodes. A node can be a root node if the node is the root of the tree. Again, it's very self-explanatory. If the node is the starting point of any tree, it's called the root node. And any other nodes apart from the root or the leaf nodes are called the inner nodes. So the question says, write a solution to report the type of each node in the tree. We can return the result of the table in any order, but what do we have to help us solve this question? We have the input, which is the tree table. It has two columns, ID and PID. The ID column represents the unique identifier for each node in the tree. So the ID column will have the node names. You can say that 1, 2, 3, 4, 5. So that is the ID column. And the PID column represents the parent node of that ID. So for ID 1, there is no parent node. That's where the parent of this first node is null. The parent of nodes 2 and 3 is 1, as we can see. And the parent of node 4 is 2, and the parent of node 5 is again 2. So ID is the node number and the PID is the parent of that associated node. Now we just have to classify each of these IDs into the three sections that we have: the root, inner, and leaf. Okay, so if you look at the output of what we want, we are classifying each of the nodes into the three categories: root, inner, or leaf. And the explanation that we have over here is that node 1 is the root node because its parent node is null and it has child nodes 2 and 3. So something which does not have any parent node is the root node. Node 2 is an inner node because it has a parent node as 1 and also has child nodes as 4 and 5. As you can see, 2 is inner because it has child 2 and 5 and the parent as 1. Node 3, 4, and 5 are leaf nodes because they have parent nodes, but they do not have any child nodes. Like, they are at the end, the terminal nodes of a tree. And we have another example which says that if there is only one node on the tree, then we need to output it as the root node. If there's just a single node, it does not have any child or does not have any parent. So how do we solve this? We can simply solve this by using a case-when statement. A case-when statement with a subquery. Now let's just dive right into it. So simply we can solve this using a case-when statement along with subqueries. And for the case-when statements, I've written these three cases that we need to write in our SQL query. And I'll just give a quick explanation of what and how this will help us. So the first case is really simple. If the PID is null, then we classify this ID as the root. So that's the first case. That's very simple and self-explanatory. The second case is to identify the inner nodes. And the way that we do it, we follow the logic that if the ID is found in the list of parent nodes, then we classify that ID as inner node. So in simple terms, if a node is also present in the list of parent nodes, that is, this node is also some other node's parent node, then we classify it as an inner node. So if we take 2 for example, it is present in the list of the parent nodes for 4 and 5. So we classify 2 as inner and everything else will be classified as a leaf node. So starting off, we have select all from tree. We just need to write a case-when statement along with subqueries, and let's see how we do about that. So if I do a case when id is equal to, we can write a subquery inside the case when. We need to just see that if the id is equal to the id when the parent id is null. So we can just say, we can select id from tree t1 where t1 dot p underscore id is null. So t1 dot id. Just to see how this looks like, I'll just quickly comment this out and only run this. Let's see what this gives us. This gives us id is equal to 1. That's exactly what we want. So in our case when statement, we are saying when id is equal to 1, set it as the root node. So I just uncomment this again. We'll say when id is equal to this, where the parent id is null, it classifies as a root node. That's the first statement done, the first case that we had. The second case that we need is if the id is found in the list of parent nodes. So simply we are checking, 2 is there in the list of values of the parent IDs that we have. So simply saying when id is equal to, again we have to write a subquery to extract everything in the parent id. So instead of equals to, I can do in select p underscore id from the tree table, tree t2, yeah, where the p, I'm just taking off the null values now, where pid is not null, and t2 where t2. If I just have to run this as a separate query, let's see what this gives us. Okay, we have the parent IDs, and when we are checking for the ID2 to be present in this list. So we can, just for the sake of it, we can do a distinct so that we get only the unique values. Okay, perfect. PIDs in 2 and 1. Perfect. So now we can use this statement. Oops, I ran this. Okay, select distinct, and if the ID is present in the list of the parent values, then we call it as inner, and that's it. Pretty much we're done. We just write an else statement, else everything will be classified as a leaf node, and we end it. Okay, perfect. So we have id is equal to 1 as the root node, we have 2 as the inner node, we have 3, 4, 5 as leaf nodes, and for the output we only want the id and the type. So we can call our new column as type and return the result in any order. Okay, perfect. We just need the id and the type column. We're all done. Let's submit this. Perfect. Hope you liked it. See you in the next.